DHCP is a very foundational networking protocol that every network engineer knows and uses. If you are not from a networking background, however, you might be curious, so we'll go over what it is and I'll show you the most simple configuration to quickly put it to work. You probably already know that the DHCP protocol is for distributing IP addresses. For your devices to work in an IP network, they require a valid IP address that is unique. It is not used by anyone else in the network. This is the most important thing that the protocol helps us with. Instead of having to ask a network administrator for an address whenever you want to connect to a new network, your device can do it for you by talking to a DHCP server that has been set up by the administrator. And that is exactly what your computer, your cell phone, your tablet, and even your smartwatch and IoT devices do automatically, because they just come with what is called a DHCP client running out of the box. Furthermore, this protocol can solve another problem. There is a limited number of IP addresses in any given network. So if devices continuously join and leave a network, such as in a library or coffee shop, you would very quickly run out of available IP addresses if you handed them out permanently. So the DHCP server only leases the IP addresses for a given period of time that is chosen by the network administrator. In RouterOS, if you don't specify the lease time, by default it will be set to 30 minutes, which is a pretty low period of time that is suitable for busy access points. For example, if your server has an address pool of 100 IP addresses available and your lease time is 30 minutes, that means that 100 new devices could successfully join your network every 30 minutes, but only if the clients don't stay longer than 15 minutes. This is because the DHCP clients have the option to renew their lease, and typically devices do it when they have reached 1/2 of their lease time, and RouterOS does this as well. Theoretically, a device that stays constantly connected to a network or reconnects before their lease time expires will be able to keep the same IP address indefinitely. Picking the lease time is just about balancing between how many new devices need to connect every day and how stable you need your network to be. If addresses are changing constantly, then you never know what addresses will be handed out to which devices, and it becomes harder to keep track of things. The administrator can also make static leases for specific clients, so that their lease will never expire and there is no need for renewal. This is neat for devices such as printers that just need to acquire the IP once and then keep it forever, so there's no guessing where to find them. Besides leasing IP addresses, the DHCP protocol allows distributing some additional information through DHCP options. The IP addresses of your DNS and NTP servers are two examples of these options. And there's an entire predefined list of values that can be communicated, but for basic configuration we don't need to worry about them. Here's how to add a simple client in the GUI. Click on IP DHCP client and then on Add button. Choose the interface that you need it on and click OK. You don't need to worry about other options. And from CLI it would be just as simple. You just need the name of your interface. As a user that just wants to access the internet through somebody's network, this is the minimum configuration that you need. But depending on your device, most likely it came with a default configuration and then you already have a WAN port that is running a DHCP client, and on top of that has a firewall pre-configured to protect you against threats from the internet. So if you're connecting to an ISP and you don't know what you're doing, just use the pre-configured WAN port. Now, if you are doing something more complex, then you can consider additional client settings. Most noteworthy is the Add Default Route setting, which is set to Yes by default when you add a client. And that is what you usually want when connecting to a single network that has a gateway to access the internet. But if you had to acquire IPs from multiple DHCP servers, then this setting could lead to unexpected outcomes, as the way that default routes work is that only one can be used at a time and the other ones are simply ignored. So sometimes you don't want a route to be added automatically. And then you got the Advanced tab, where you could write an entire script that gets executed whenever this client acquires an address, applying whatever configuration you need. And of course, you could also manually add specific DHCP options on top of the ones that are already used by RouterOS in the background. And you can change the default route distance if you do use the Add Default Route setting. Finally, you get the Stats tab, where you can see the information that has been acquired by the client. Next, let's create a DHCP server from scratch. This will be a little more complicated, but we'll do the minimum to make this happen. So first, we need to add a new IP address on the interface that will be running this server. I have picked an address with a /24 local network that I can use for my leases. Now, there are a couple of ways how you could do the next steps, but ultimately what has to happen is that in this IP pool section, you would have to create an address range that will be used for leases. It would have to be from the same network as the address that we just set up, but I won't do that now. Then on the DHCP server section, a new server would have to be added on the DHCP tab, and then a network should be again defined in the network tab. The reason that I am not adding them manually is because of this neat DHCP setup button. I highly advise to use this feature if you are new to this, as it will take you through the most simple step-by-step process possible. When I click it, I'm prompted for the interface that I would like to use, and here I will indeed use Ether 8, that is where I have set my IP address on. And when I click next, the DHCP address space is immediately autofilled based on the IP address that I have on Ether 8. This is exactly what I need. Next, the gateway for DHCP network, again autofilled to the IP of Ether 8, that is correct. Then I'm prompted for the address pool, and it is autofilled to an address range from 2 to 254. You can alter that if you want, but it is functional range. The DNS server again autofilled to the same address that my router is already using. Finally, the lease time of 30 minutes looks good, and that completes the setup. I can now check what changes have been made. On the IP pool section, there is now the range we chose. We could edit that if we needed. Then the server was added with the minimum settings, interface, lease time, address pool, and then a basic network was defined for the server. Since I have a DHCP client already connected, I can go to the Leases tab. The IP address ending in 254 has been handed out. And if I wanted, I could make it static, and this DHCP client would always get the same IP address. These were the most basic steps that you can take to put DHCP to use if you have never done it before. If you want to learn more about RouterOS and networking in general, make sure you are subscribed to our YouTube channel.